In this sketch, we present a real-time algorithm for skin rendering used in the animation Ruby, the Double Cross, which is showing in this year's SIGGRAPH Animation Theater. Our algorithm is based upon the SIGGRAPH 2003 sketch on realistic human face rendering for The Matrix Reloaded by Borshakov and Lewis. This approach is efficient and reasonably simple to implement, but achieves startlingly realistic results. There are 4 main steps to our algorithm. First, we render the diffuse illumination to a 2D light map. Second, we compute and store shadows in the light map. Third, we blur the light map in texture space. And finally, when rendering our final mesh, we use this blurred 2D light map to provide our diffuse illumination. As mentioned earlier, we first render the diffuse illumination of our character, in this case just the head, into a light map. This operation is performed in real time every frame. To simulate the look of subsurface scattering, we apply a variable-sized Poisson disk filter to our light map. The size of the filter kernel can vary spatially in order to account for varying texel density in the original mesh, and to account for areas on the character which are more affected by subsurface scattering, such as the nostrils and ears. We also generate a shadow depth map for the key light and apply this to the character's light map in texture space. You can see here that the illumination in the light map varies each frame, as do the shadows. As a nice side benefit, the blur operation also provides soft shadows at no additional cost. Shadows cast by translucent objects, such as this character's sunglasses, can be computed using a hybrid projective shadow algorithm. As we are rendering the shadow map, we write a transparency value to the alpha channel. When applying shadows to the light map, unshadowed pixels are attenuated by the value in the alpha channel. Since it would be fairly expensive to perform an independent blur pass for the shadow component, we cannot directly apply shadows to the specular illumination. However, we get a good approximation by computing the luminance of the blurred light map and using that result to attenuate the specular term. In order to prevent boundary artifacts when fetching from the light map, the texture needs to be dilated prior to blurring. We accomplish this by modifying the Poisson filter to check whether the sample is just outside the boundary, and if so, copy from an interior neighboring sample. We only need to use this modified, more expensive filter in the first pass of our multi-pass blurring process. We have presented a real-time algorithm for skin rendering used in the animation Ruby, the Double Cross, which is showing in this year's SIGGRAPH Animation Festival. We have demonstrated a technique for real-time texture space lighting which simulates subsurface scattering with a variable-sized Poisson disk filter which is able to selectively dilate the light map to eliminate border artifacts. We have also shown how this technique integrates with shadow mapping to achieve soft shadows, including transparency and a convenient way to mask specular illumination. And finally, we have developed several culling techniques which take advantage of early Z culling and modern graphics hardware to achieve optimal performance. We refer you to the paper for details on the culling strategies.